Welcome. Good afternoon, everyone. So I will demonstrate today Podman and Podman Desktop. My name is Florent Benoit. I work for Red Hat, and I work on the project Podman Desktop. So before explaining what is Podman, could you raise your hand if you are already using or know Podman? Okay, thanks. So each time that you will see Podman, you will see some little cute animals, the seals. Maybe you don't know the relationship between these cute animals and Podman. So in English, when you have a group of seals, it is called a pod. And to be able to handle or to manage the pods, you need a manager. Then you have pod manager, and the short name is Podman. This is the origin of the name Podman. So today, these cute animals are greeting you, so you can say hello to the seals. It brings me to the key point of Podman. The first point is that it's fast and light. Why? It's daemonless, so you don't need a client and a server. When you want to run some containers, it will just execute the process, and at the end, you exit, then nothing is running anymore. It brings us to the next point, which is the security. As it's daemonless, the permissions are granted to the user that will execute the containers. So if you are like a plain default user on a Linux system, you will get the permission, and you will be limited in the permissions that you can do. This is what we are calling the rootless mode. Of course, if you want more access, you can use the root user, and in that case, you will get more advanced permissions. Podman and Podman Desktop are open by default. We are using the Apache license 2. And even in Podman Desktop, we have plugins to run and to discover the Docker containers, the Docker images, and the support of the Lima provider as well. The last point is the most interesting point as a user. It's that Podman is compliant with the OCI images. So it means that every images that you are able to build, run, push, or pull already on using Docker, you can do the same using Podman. So it's compliant. In addition to that, Podman is emulating the REST API of Docker. So you can have some clients connecting to Podman. Let's say I install Podman on my MacBook laptop. I will get a CLI, like a random CLI, and it's close to the Docker CLI. You may have the same commands that the Docker CLI. It will differ on some advanced parameters, but basically the basic commands are almost the same. So with that, you are able to build, run, and work with Kubernetes stuff. One example, the images. So of course, with the CLI, you can use a search command if you want to search some images. You can build or pull images using the Podman build, Podman pull image. And of course, you can push back the image to a registry. When you have images, you want to run these images. This is the containers. And for that as well, you have the Podman run command, and with all the command line options like listen on this given port number, use it in the background, stuff like that. So here, I just gave you an overview of Podman CLI. It's almost the same as the Docker CLI. But we have more capabilities in Podman. So in the name Podman, we have the name pod. So it's possible, using Podman, to have a single unit of a list of containers. It is called a pod, and all the containers are sharing the same networking and file system. So if you have some application using multiple containers, you can group all the containers inside the pod, and this will be your deployment unit. You bring the pod up, your application is running, you can remove the pod, the application is gone. Each time that you have a pod that is running, you have some commands like Podman cube commands, where you have the ability to extract the cube YAML file from your pod. So let's say on my Podman instance, I have a pod. I can extract the cube YAML file of my pod, then take this YAML file and deploy it to a real Kubernetes instance. I can do the opposite. I can take one YAML file which lists all deployments of pods using a Kubernetes cluster, and I will use the podman kube apply command, and it will deploy all the containers using my local instance. As we have the compliance with the REST API of Docker, if you have the compose binary installed on your computer, what we can do is that podman space compose will call the compose binary on your computer and will set the Docker host socket, the Docker host environment variable, to the Podman socket. It means that you will have the compose application running, but using the Podman engine. Usually you have some tooling on your computer that is already configured to use Docker. So we have some helpers in Podman that will bind the system socket. So for example, on Mac or Linux, it will be the var1 Docker sock. And in that case, all the tools that you have will be able to connect to the Podman engine instead of the Docker engine. Doing that, you can even use the Docker CLI, and it will be connected to the Podman engine. Of course, you won't be able, in that case, to run some pods. We have the support of WebAssembly, so it's possible when you are building images to use a platform for WASM. So it's possible to build the image and then to run the image as well. All these projects, Podman Desktop, and other projects are part of the GitHub containers organization. And you have a lot of different tools dedicated to some specific tasks like building images, copying images from registries to other registries and stuff like that. They are all open source as well. Okay, now what is the difference or the relationship between Podman and Podman Desktop? So Podman Desktop, it's a desktop application that will work for all the workloads that is possible using Podman. So you can use Podman Desktop to handle the containers, the compose application, or the pods. But sometimes you want to run locally on your laptop a Kubernetes cluster. So Podman Desktop will ease that for you. We have some extensions, some plugins, where you have the ability to create some clusters. So using Podman Desktop, you can create a kind cluster, a Minikube cluster, running inside your Podman machine. And in that case, it's possible to take one container running locally on your Podman instance, make it like a pod compliant, and then deploy this pod to your Kubernetes instance. So I think I've done too many slides, so we'll do the demo. So let's say I have a command line tool. So as I said, it's possible to do the build and run of your container. And here it's just for running and building the WASM example. So podman run, podman build. And I will just show you that it's possible as well to run some compose project. It doesn't matter the kind of application that we have. So now, if we go back to Podman Desktop, we have a list of all containers running inside my Podman machine. So the Podman machine, it's a Linux VM where I can execute all my containers. And we can see here that if we have some application, like penpots, which is a compose application, it's group here. And if I have a container, for example, the database container, I can click on it. I have the logs. Maybe I can zoom in. Then I can get the cube YAML file of my container. So using that, it's possible to then deploy your container to a kube instance. And I have a terminal tab where I can execute some commands, like listing what is inside my database container. So here we have all the containers. In green, it's all the containers that are running. You can see the containers that have been exited, so you can clean up. You can have some operation to select all the containers. You have all the running. Here you have the pods. So here we are listing both the pods from Podman, the Podman engine, and if you are connected to a Kubernetes cluster, we will be able as well to list all the pods here. You will just see here the difference between Podman and the Kubernetes cluster. Then you can manage all the images. If you want, you can pull some images like HTTPD. So it will try to see if we are able to pull some instance, and that's all. We have the volumes. Then the interesting part is the extension. Here it's possible to bring new capabilities to Podman Desktop, installing extension. So we see that we have some Docker extension, kube extension. So it means that when you go to the resources here, it's possible to create some kind cluster or Minikube cluster. So if you really want to deploy some Kubernetes stuff locally, you can use that. Before going there, I have already created a kind cluster that is running on my laptop. So let's take now a sample where we have the Redis application, the database, and a front end. It's two containers. Here, I can ask to open the application. So each time that I refresh the application, it just adds +1. But I have like two containers. So the idea is that I want to be able to make a pod from these two containers. And instead of exposing the ports to the outside for the database and for the front end, I just want to expose the front end port. So here, I disable the expose of the database port to the outside, but inside my pod, my front end will be able to connect to my database. And I will call my pod like random them. So here, Podman Desktop will take the two containers, create a pod, and bring the two containers inside the pod. We are redirected to the pod view, and we can see that I have a new pod here. And if I go back to the container view, here we can see that we have the two containers, but it's strange, we have an extra container. It's the infra container. Every pod has an extra container to manage the life cycle of the pod. I still want to see if my application is running. So I will try to connect. Of course, as it's new containers, new state, it starts again to 1, but I'm able to have my application running. So now what I want to do is, okay, I have my pod running on my Podman engine, and I really want to move this pod to a Kubernetes cluster. So for that, I can use a deploy to Kubernetes. Okay. I will click that I want to have a cluster. And if I go to localhost 9090, there is nothing running for now. Now I'm clicking on deploy. So it will extract the kubeyaml file from my local pod and apply that kubeyaml file to the Kubernetes cluster. So we can see it's already running. So if I go back to my pods view, sorry, here I have my pod running on the Kubernetes cluster and the one running on the Podman engine. And as Kubernetes cluster listening on this port, here I'm able to execute the application running in my kind cluster. So I was able in few clicks just to move my containers to a group of containers, a pod, and migrate this pod from a local Podman engine to a real Kubernetes cluster. And of course, here you can see that it's Kubernetes, and for the other, it's Podman. So in this view, we are able to see both Podman and remote clusters. In Podman Desktop, you can also connect and bring new registries. So you can connect to a lot of registries, so Docker Hub, GitHub, and others. And you can select as well the Kubernetes context. So let's say you have multiple clusters connected to your local laptop in your kube config file. You can see all of them here, and you have a way to switch from one to another. And you have the Kubernetes view. So if I go to the service, we can see that now I have a new pod service that is listening. This is my pod application. Here again, and that's all. So here we can see that we have some view in Podman Desktop that allow us to discover and use all the Kubernetes deployment stuff. One advantage of Podman Desktop, it's an application that can just stay in the tray icon on Mac or Windows, and it will keep up to date the Podman engine. So each time that there is some updates, you are notified, you can do the update, and each time that you start your laptop, it will start the VM. So it's a nice enhancement when you want to just work with containers. So here I already said that you can connect to other OCI registries. We can manage pods. And of course, you have the Kubernetes integration. So I did some demo here. So as you have seen, we have a lot of plugins to extend the behavior of Podman Desktop. So behind the scene, Podman Desktop is using a Tailwind and a Svelte framework to do the UI. It's working both on Windows, Mac, and Linux. And for that, we are using the Electron. So there are pro and con here. And one interesting part is that on Windows, we are supporting WSL2 and Hyper-V for the VM to run the Linux VM. On Mac, we are using the default Apple hypervisor. But since a few months, we have brought a new kind of engine, which is libkron. And if you are doing AI stuff, it's very nice because in that case, you can have access to the GPU from the containers. So sometimes we are listening, okay, it's nice, I can run all my AI stuff inside containers, but it's slow. But now, as you have the GPU pass-through inside the containers, you have a direct access to the GPU. Then you can deploy all the workloads using a native access to the GPU. And on Linux, we are just using the native access. So if you have Podman running on your system, it will detect and display all the containers inside of Podman Desktop. One thing is that we have a lot of extension and a lot of extension points. So you can customize a lot of menu, a lot of context menu. You can add new registries with the extension. You can customize the colors. You can do a lot of stuff. And it permits us to be able to deploy as well the Docker Desktop extension. So some Docker Desktop extensions that provides like UI, we are able to deploy them on top of Podman Desktop. So for example, we have I think the 3V extension that is doing the scan of images that we can just drop and install in Podman Desktop. So now I will introduce you like the dedicated extension that we have. It is called Podman AI Lab. It is one extension where it's a way to run all the models, all the LLM models, using containers on your laptop. So sometimes you want to just try models locally to switch, to compare the models. And with Podman, we have this capability as well. So here I just go to the AI Lab entry. And when you go there, you have a list of examples. So you have like a chatbot application, summarizer, kind of basic sample. And if you go on each card, then you will be able to run some sample. So before going to the session, I've already launched this kind of application. So you have some example like object detection. So this time, instead of using the cute animals that are the seals, we will use cat. So the idea is that, okay, maybe you don't see, but it's able to detect that it's a cat. Yeah. So here, it's using the AI models that are running inside of containers. So again, you have the sample for the chatbot. So here I will not go deep in the detail of how to write the chatbot. But if I'm asking some question to the Podman AI Lab, it will ask the model running locally. So even if I unplug my internet connection, it should be able to answer. So here you have the models. So each service is an instance providing the access to the model. So for example, here we can see that I have this model, and we can see that there is a GPU access. So it means that we have here the capability to access the GPU from the container. And you can connect using a Swagger API here, and you can just execute your query, and it will reply to you. Okay, yeah, it's what is the capital of France, and its price. So when you want to just try some models, you can use catalog services. It will just run the models on top of a container, and you have a service to access to the model. So you can use the Swagger API, but if you want to use different snippets of code, you can go there and you will be able to select, like, I want Java and I want Quarkus long-chain for G sample. So here you can do some copy-paste and you will be able to run all the samples running on your laptop. So sometimes you just want to do some query. So here I just want to compare some models. So I would say, for example, I would take this model, I will create a playground, I connect to this playground, I will just ask the same question. So sometimes you just want to compare models and see the response. So here you will see this kind of response using this model. And you can say, okay, I have seen the response. Then you switch to another model. And you can do the same question. Of course, you can change and tune the parameters, but then you are able to see, okay, it seems that with this model, I have more details response. Another example is that here in the status bar, you can see that AI Lab API is listening on a given port. And if I go, for example, here, if you have the Olama tool, you can say, okay, for the host of the Olama client, I want to use the Podman AI Lab backend. And using that, it means that you can list all the models running inside containers inside of Podman. And then you can use all the Olama tooling to do that. So to conclude, if you are interested in using or installing Podman or Podman Desktop, you can go to the Podman.io website or Podman Desktop.io website. From there, you can download and try Podman. If you are finding some bugs, you can report them on the GitHub tracker. You can add some stars if you really like the project. And if you want to engage with the community, the Podman community, we have some chats and we have some Discord chats as well. So that's all for me. Thank you for being there.
All systems are nominal. Initialize Genesis sequence.